Please, if you can bear with me, I would ask us to use this front, because it's going to be a very small, if we can use this front end part, all of us, so we have an intimate session, so that we're much close to each other. We can use this front row. I don't think we're going to fill up to the end. Ladies, if you can bear with me, please, if you can come and sit up here front. It won't show that we are in an empty hall. Come, sir, we are sitting in front. I also want to ask for a volunteer who is going to be our rapporteur for this session. A rapporteur, somebody will take notes for this session. We need to come up with a combined resolution for this session. So I need someone who can be able to write some few notes for us that we'll take to the plenary after the end of the session. Someone can volunteer. We're going to have some papers and some questions, and then some people have some suggestions and discussions, and I need somebody who can just pick up the most important points that can be. You volunteer? Is Refile? Liseho. Yeah, Liseho. Yeah. So Liseho is going to be our reporter to take out some of the points and questions that will come out of this session. Let's wait for a little bit, because there's some people who went to lunch very late. Let me just check, give them some more 5 minutes, and then we can start our session. I also don't know if our presenters are all here. Please, if you can raise your hands. Is it 4 presenters? 4. Okay.
No, there should be a computer somewhere here. These are just. Let me ask these guys. Okay, good afternoon, everyone. Salibonan. Now it's afternoon, I can't say huimo. Can I say huimo again? We want to start our session now. I attended the previous session on power and renewable energy. It was a little bit overheated with discussions on the matter that was being presented here. So I welcome you all to this session. This session is supposed to take 1.5 hours, but I think it will overflow to some hours, or it can take less. My name is Clever Banganai, so I'm not Professor Nyembwe, as it is said that we swapped with Prof, because I am not versed with the issues of the other panel, of the other session. So, like I said, my name is Clever Banganai. I'm going to be your chair for this session. I'm from EXA. We've got 4 presenters that are going, I think so, we've got 4 presenters that are going to present papers which are related to power and renewable energy. These are technical papers, just to say to our audience, these are technical papers, these are research topics that some of the students or researchers would have gone through their university. They are not policy documents. So when we discuss, we interact with them, I understand there is a lot of frustration about policy and issues of where we are going as Africa on renewable energies and so on. But bear with us that some of the people might not have that expertise in the field because they are still researchers, they are still students at universities. So we would encourage you to please pick up some of the things. I'm not trying to limit the questions. It will be fine because when we get questions, I think we would also open up to the floor if there are people who want to engage with that and to give opinions and so on and so on. Besides, outside the papers that are being presented there, we can allow that to take place. Please, ladies and gentlemen, please, we are using this front row. I said I'm going to act as a moderator, but also as a headmaster. please come and sit in front so that we can be close to each other and we can understand. So we've got these 4 papers that are going to be presented here. Like I said, my name is Clever Banganai. My background is academic and industrial. So I spent a lot of time in academics, and I spent a lot of time in industry. For some time, I'm still in industry now. So I got that balance of academic and industry experience, which stretches more than 20 years. My field of expertise and interest is, it varies in quite a number of fields, but I'm a metallurgical engineer by profession, specializing more on the engineering part of metallurgy, not on the extraction part, which is more of chemical engineering, sort of. But I'm also into mining. I've ventured into mining, into consulting, more onto issues that deal with the supply of materials to industry, as input materials to different types of metallurgical industries and the power industry. I spent a lot of time in the power industry, so I've got quite experience of the power industry. I'm a cable builder, so I build cables, power line cables. So your cables for your distribution, your house wires, your transmission lines. So before they go to ESCOM, we're in charge of actually making the cables. I see there's a topic here on the detection of faulty cables that can cause some problems in our distribution. So I got quite a lot of experience in that. I spent some 12 years building cables. So I know the cable industry very well, from processing the whole value chain, from where you get your materials, your aluminum and copper that goes into your cable. Like I said, I also spent a lot of time as a senior lecturer at one of the universities here in Johannesburg. We are going to have a robust discussion, I hope so, on this engineering week, African Engineering Week, in collaboration with the UNESCO and EXA. We're trying to get as much as possible to get our own African solutions to our African problems. And therefore, that's why we have this conference where we bring in all experts of engineers around Africa, and some obviously will come outside the continent, but mostly would encourage them to come from the continent. We received a quite number of these papers that are going to be presented today in different days from today until Wednesday or Thursday in different fields. Some are in water, as you can see, we are in power and renewable energies. There are some in built environment and in many other fields. I also want to say that when we finish this section, we must come up with some sort of points that we can say we summarize our session and therefore give the contribution to the broader engineering week of EXA. Our presenters here, just to give you a dry run, your papers have been loaded. We've got this control here that you can use to move your slides up and down. You've got some time allocated to you. I'm going to use like a referee here. I've got my red card here that I'm going to show it to you when your 5 minutes is up. And then you can wrap up, and then we get to the next speaker. Then I think at the end, we can then ask questions from the floor, and I'll allow you to answer those questions that are coming in. I'll also have some few questions that I can ask from you. So without much ado, Can we please load the presentation for Mr. Is it Gideon Kiabadise? I don't have your CVs here, so you can just give you a short brief where you come from and what's your research. Please, can we give a round of applause to Gideon for his first presentation?
Thank you very much, Chairperson, and good afternoon, ladies and gentlemen. As the Chairperson has indicated, my name is Gideon Kepadise. I work for Transnet Freight Rail as a signals engineer, also known as signals as train authorization systems engineer. I'm a master's candidate at the Northwest University under the supervision of Professor Peter van Vuren. I hope all is in order, and you'll be very happy to know that my topic doesn't involve controversial issues as we have discussed earlier on, and, and there is no reason for you to be grumpy because you just had a delicious lunch, so really just relax. And just before I start, let me just humble myself, Chairperson, to say that I didn't bring with me a silver bullet to the problems of cable fault detection. But what I've hoped to have done is to add just a little bit more towards the solution in terms of early detection of cable faults. So here we go. Okay. There we go. All right, so as I've said, my research topic is about early detection of potential cable faults on underground low voltage cables. And for today, we're just going to focus on a review of suitable techniques. Just to give you a brief overview of what I'm going to talk about today, first I'm going to give, so that we have an understanding of what is a train authorization system, so in terms of rail network, and then I'm going to talk about the various cables and that are used on the test system, and I'm going to talk about the categories of low voltage cable faults. And then after that, because ultimately we want to get to the point where we are able to identify a technique that will be suitable for detecting potential cable faults before they become permanent. And I'm going to talk about those techniques. And then after that, I'm going to talk about the criteria that I'm going to use to decide or help us to get to a solution of the best suited technique. Okay, so here we go. So train authorization systems, it's a very simple system. It is a system that is used on the South African rail network to safeguard, to ensure the safe movement of trains. It's as simple as that. How it also has an additional benefit in terms of increasing the line capacity by decreasing the following distances between the individual trains, and also, very important, it prevents conflicting movement of trains that are moving on the same line, and it also predetermines the safety integrity of the rail infrastructure before we send our trains out there. Now, you will see the figures below. The first figure, just to give you a mind map of what is happening when we talk about the train authorization systems. You'll see on figure 1, we have what we call the centralized traffic control center. This is where all the human operations, all the commands are sent out to say which train must move from where to where. And then figure number 2, it's what we call the relay room. This is where all the logic happens in terms of interpreting the logic that was sent from figure 1, and they are then interpreted and processed, and then they will be sent to what you can call, if you look closely on figure 3, to what you can call a train traffic light, but we call them signals, right? So now the issue that we are currently facing, and this is what I'm going to talk about mostly, it's what's happening is the communication medium between figure 2 and figure 3, and those are copper cables. That is where 90% of our issues emanate from. Then we have, just to give you an idea of the cables that we'll be studying, we are going to be studying train authorization cables, which are low voltage copper cables. These are armored cables. They are buried underground at any level between 1 meter to 2 meters. Obviously, we're trying to curb the escalating copper theft within South Africa, which is a very big problem as we speak. And these cables, they carry a voltage of anything between 220 volts to 440 volts AC. And in terms of DC, we have 110 volts. And then we have the various sizes in terms of cores of the cables, from 1 to 64 cores. And then a typical a new cable, you will see on your picture that is on your left, that is a typical 3-core cable that we use for, it's a new cable that we use for tests. And then this very same cable you can see, this was somewhere in Mpumalanga where a cable has failed, and we dug it out and we found that it was in that condition. And close inspection, we found that all the inner cores of the cables were flooded with water. So that we can be on the same page, I've used the South African national standard just to give you an overview of the classification of voltages within South Africa. You will see that any voltage, AC voltage that is below or equals to 1 kilovolt, it is classified as low voltage, and then anything that is above 400 kilovolt is classified as ultra high voltage. Now, before we even go and try to solve the issue of the cable faults, we need to understand what exactly causes these cable faults. Now, within the railway infrastructure, we have a serious problem because this infrastructure has been working for more than 5 decades. And you can imagine that most of these cables have long reached their life expectancy. So then you're going to have issues of aging on the insulation or degradation. Because they are buried throughout the length of South Africa, all of these cables. And if that happens, if the insulation fails, then all your issues start because you'll have cable faults left, right, and center. And then another issue that causes cable faults is incidental damage during the repair process. If you can just have a look at that picture at the bottom right, I took that picture on site, and one of the workers incidentally just damaged the insulation. It's not his fault. We didn't know where the cable was. We were just digging, right? So once the insulation is damaged, then within a month or so, the cable is going to fail. Another issue that is rearing its ugly head is the theft and vandalism, because they are after copper to sell it for scrap yards. So once they steal the cable, and we need to join it back, and the process of joining introduces weak points within the cable, and that also contributes to the failure of the cable. Another issue is while you are joining the cable, you find that some of the workers, they don't join it as they should, and then later on result in a cable fault. So in a nutshell, these are our issues when it comes to cable fault detection, causes of cable fault. Now, we further go down to categorize the types of cable faults. Really, we just have 2 types of cable faults in terms of categories. The first one being the insulation faults or the shunt faults, and the second one being the open circuit fault. The open circuit fault is not really interest to me or any other researcher because in this state, the fault has already occurred. There's nothing more you can do. There's just a physical separation between the conductors. All you can do is to replace the cable. Now we need to go back to the shunt faults. We can break it down further to 2 categories, which is the low resistant faults. This happens when there is a short circuit between one or more cores of the cable. And now going to the area of interest, the faults that we can call high resistance or intermittent faults, also known as incipient faults. Now, incipient faults, they've got the characteristics of self-clearing, meaning that it's a fault that can occur for a short period and then it clears itself automatically. So you won't be able to detect it because it happens for such a short period. Some scholars suggest that it happens for a period less than a quarter of a cycle. Some say a period less than half of a cycle. So you won't be able to detect, but if it persists, then it will eventually lead to a permanent cable fault. And this is where we are interested in. We want to be able to detect this kind of fault so that we can plan our maintenance. Once an incipient fault occurs, once a cable insulation damage occurs, we can be able to detect, then we can plan our maintenance of how we are going to replace this cable before it leads to catastrophic failures that can cost us, as I will speak on the next slide. Now, at the moment, we are unable to detect the failure of the cable before it fails. So if that happens, if the cable fails, it means that the train authorization systems that we so heavily rely on will not be able to function. Therefore, we won't be able to determine the safety integrity of the infrastructure, of the rail infrastructure before a train movement happens. And what we're currently doing is to fall back to what we call a manual train authorization. Now, manual train authorizations, it's basically a person communicating via a cell phone or a radio with a train driver to tell them their position. And you can tell there are so many trains that a single human being can keep track of. And that is also automatically leads to what we call human error problems. And obviously, they also cause train delays and sometimes train collisions. And at very least, we can even derail the train and lose a lot of infrastructure. It's a very costly thing to happen. Now, with the train delays and cancellation, they also impact, because you may be sitting there and asking, yeah, so what? So they impact the South African economy in the sense that you will then have delays on the imports of fuel as well as automotive parts to South Africa from other continents or countries. And then you also have delays on the exports such as coal and iron ore. So that is going to cost us severely. And then if there is a train derailment or train collision, if you can just see on your on that picture on your bottom right, there can be loss of life, unfortunately, and at the very least, environmental disaster. So this is why we are saying we need to really find these faults before they cost us. Now, in terms of, while I was doing my literature review, these are some of the major points that I came up with. And what I've realized is that most of these studies for early potential fault detection on cables has been done on medium to high voltage cables, and very few have been done on low voltage cables. And that is why I decided we need to really look into this and contribute towards improving that. And unfortunately, as I was studying and doing my literature review, I realized that underground power cables are very challenging to analyze. Maybe it explains why you have so many scholars studying them. And it requires complex analysis before you can even isolate or detect them. But what I'm trying to do is to adopt several techniques that has been developed already for high voltage applications and try to apply them for low voltage underground cables. To do that, I've identified 3 techniques, and due to time, I'm not going to exhaust all the list. First, we've got the partial discharge measurements. Basically here, we're just measuring, we're just sending a high voltage through the cable and cable insulation. And if there is a discharge on the cable insulation, it means that the cable insulation is compromised. Now, the advantage of this is that obviously this method has been studied extensively, which can also be regarded. It has been studied extensively on high to medium voltage power cables, but not really on low voltage cables. The second technique is the time and frequency domain reflectometry. This method has also been studied, but they are highly, highly sensitive to noise and attenuation, which can be a problem if you're considering the railway infrastructure environment which we are talking about. Another technique that is promising is the broadband impedance spectroscopy, which is related to the frequency domain reflectometry. Now, this method is promising because some studies have indicated that it is able to detect incipient faults, and it can be applied to online cable monitoring. And just, you will note that I've repeated some of the words, but just excuse that. Now, as a summary, this just repeats what I've spoken about. If we just look at the last point, which talks about the broadband impedance spectroscopy, is that this method is, although it's still under development, it has shown that it has so much potential to solve the core issue that I'm trying to solve with this research. And we can further just break it down into mathematical models in order to simulate and be able to do mathematical models and do simulations using Python. And these are just the propagation constant, which you can see on equation number 1, and the impedance, which you can then apply on the transmission line theory and calculate the input impedance, which is shown on equation number 3. Now, to evaluate these techniques, I'm going to use this criteria. The first one, we're going to look at the method's ability to detect major insulation breaches. By major insulation breaches, we mean those holes or cracks on the cable insulations that make their way to the cable conductor. And then category number 3 and 4 are very important because the technique needs to be able to detect the aging of the insulation as well as the degradation and the ability to detect incipient faults. And last but not least, point number 7, we need to know that we can practically apply this method on the field. As I conclude, Chairperson, what I've said is that all these methods that I've spoken about, we need to further do a validation and verification of these techniques, and we'll do that by conducting Python simulations, and then after that we will go to do lab experiments at the university. Then we can try them out along the rail network infrastructure. Ladies and gentlemen, these are just my contact details. In case you want to DM me, there are the contact details. And I thank you so much. Ndiyabonga, zikhensile. Thank you.
Thank you so much.
Thank you, Chair.
Can you give me again another round of applause? So please, ladies and gentlemen, just note some questions for him. We'll come to him at the end of this session. Our second speaker is Boniface Kangire Tambro. Please, if you can come. His research is on mesophilic batch anaerobic digestion of wet black wettle leaves and cow manure mixture for methane production as part of the renewable alternative sources. Mr. Boniface.
Yeah, thank you very much, Chair. As he said, my name is Tambro Boniface Kenjiri. I completed my master's with Nelson Mandela University. Me coming here is being sponsored by Walter Sisulu University, and currently I'm working with a company called Cape Advanced Engineering. I'm currently part of a team where we're building a biogas for Limpopo dairies. Yeah, as my topic goes, mesopholic batch anaerobic digestion of wet black wattle leaves and cow manure for methane production. Sorry. Yeah, for methane production. I know, why is the yeah. Can you help me here? I think it goes and it doesn't change. Yeah, okay, yeah. Black wattle, from my slide here, you can see the black wattle leaves. I know some of you don't know about black wattle. It's an invasive plant that grows very tall in the Eastern Cape of South Africa and KwaZulu-Natal of South Africa. This invasive plant takes a lot of water from the soil. So due to its nature, doesn't allow other species to grow around. In this case, other plants, other animals are not able to get grazing feed to feed on. So the ideas came about. The government invested a lot of money in 2003 to eradicate this plant, but then he couldn't finish that because the plant keeps growing very fast. So I came with the idea of using this plant to produce energy as a biomass. So it came in mind of biomass to bioenergy. And when you think of biomass to bioenergy, the first thing that comes in mind is anaerobic digestion. We have anaerobic and aerobic, but I went for anaerobic digestion. With anaerobic digestion, you try to eradicate oxygen from the system and allow bacteria to feed on the feedstock in order to produce gas. So it was the first thing I looked at. And then I also looked at the types that we have. We have the batch system and the continuous flow system. So with the batch system, you feed your digester, and then you allow it to produce gas after a certain period of time. But with the continuous process, you have to continue feeding your bacteria every day or every time. So with this, I decided to go with the batch process. And I realized that there is a lot of parameters involved when it comes to biogas production. There is temperature, there is pH, there is a lot of them. But the most important ones I will explain as I move further. Yeah, this is the layout of what came in mind and what I intend to do. Due to this nature of this plant, being an invasive plant, when we harvest this plant, what are we going to do first of all? So that is where the problem started coming, and we realized that after harvesting this plant, we have to use the stem side or to produce firewoods and charcoal and etc. Also, the leaves side, what do we do with it? Do we burn it or do we throw it away? So I also came to a conclusion of, okay, why not push the leaves into a storage and pre-treat them and see how it goes? But then when I pre-treat them, still it doesn't have any use. So my focus area falls under the green side that is highlighted, pushing the whole leaves into a digester. But now, from literature, I realized that this plant has got a medicinal property. And the medicinal property that it has got, it's going to be a bit of a challenge when bacteria wants to feed on this plant. But then I said, let me give it a try. So I took cow manure, put it aside, and then took the black wattle, and then mixed it with cow manure, and then left it for a couple of days just to see the amount of gas that I'm going to get. But then I wasn't recording the amount of gas or to test, I wasn't recording the quality of the gas. I was just only trying to look at the amount of gas that I was going to produce. And it took me almost 35 days without getting anything. So after 35 days, I said, okay, let me allow it for a few days. And after 60 days, that is when I saw that the gas content started coming up. So I realized, okay, I have to find an approach in order to produce gas with this feedstock. Now looking at the yellow side, that is, after producing the gas, you're going to get a digestate. And this digestate, you can't just throw it away. You have to also make good use of the digestate. And I realized that it can be also good for compost making. So the yellow side is for compost making. It explains how the process involved, whilst the blue side also explains how you're gonna use it for clean and coal making and everything. But my focus area on this particular research is on the digester producing methane with this feedstock. I'm also not looking at the storage and scribing. That means getting the quality of the gas or its usage, but then to see the quality of methane that I was gonna produce. Yeah, so here comes some of the objectives that I thought of. To determine the characteristics, effect of the acacia mensae for biogas production, the effect of mixing mass ratio, that is black wattle to cow manure. The challenge here is that a lot of people who are into biogas production struggles when it comes to mixing of the feedstock. So I thought of it as one of the key points that I can rely on just to see when I mix, what am I going to get? I also wanted to determine the effectiveness of draining and drenching. That is inoculating the process. When I say inoculating the process, this time around, I am bringing the bacteria to the feed. So I starve the bacteria in another reactor. I'll call it a mini boiler. Starve them and then take them to the feed and see how effective these bacteria will consume the feedstock and produce methane. The other one is also the effect of suitable process parameters. That is the challenge that we have, especially when it comes to selecting parameters for gas production. So what parameters is it important in terms of producing biogas? Which one are you going to look at in order to say that when you take this and take that and take that, it's supposed to give you this amount of biogas? So that was also in my objectives, and also understanding the influence of the pH and carbon-nitrogen ratio and their least effect, and also to build understanding of the biodegradability, how these bacteria act on this feedstock in every stages in the reactor, inside the reactor. So now, this diagram here is showing the biodegradability stage of the organic materials. We have the hydrolysis stage, that is the first stage, and then we have the acidogenesis stage, the acetogenesis stage, and the metagenesis stage. The hydrolysis stage, this time around, is when the bacteria are consuming organic materials to produce monomers, volatile fatty acids, in the system. Whilst during the acidogenesis stage, acetogen bacteria also consumes the polymers and the volatile fatty acids to produce acetate and carbon. And then when it comes to the metagenesis stage, that is when methane bacteria consumes this acetate and carbon dioxide to produce the methane. So I was looking at these steps to see what literature says about this and how I can really focus on this in my experiment. Looking at the important process parameters, I realized also from literature that temperature is very, very important. pH is also very important. The duration at which the process is going to last is very, very important. And the carbon-nitrogen ratio was also very important. Sorry? So I did feedstock analysis, and with the feedstock analysis that I did, this was the results that I got from my analysis. And then after getting these results, I pushed the whole thing into my reactors. This was designed in a way that we have the mini boiler, and we have the reactors at the top, and we have the volumetric water displacement. That is where I was collecting my gas. So I pushed my feedstock into it, and also with the mini boiler, I put in inoculant that I was going to use to inoculate the process. So doing this was the results, the outcome of the experiment that I got. I end up monitoring with a temperature logger that are connected to the whole system. I was monitoring the atmospheric temperature and then each reactor temperatures. And then also I was collecting biogas every 7 days just to also see the biodegradability stages. So first 7 days, I collected the gas to check the quality of that gas. And that is the results that I'm also getting on the two graphs on the left-hand side. Now, this is a breakdown of the whole gases that I tested with Optimus 7 biogas analyzer. I was getting all these gases, which is more detailed in my article. The impact and the significance of this finding in South Africa is that we all know we have energy crisis in South Africa. And therefore, this particular area is very, very important in the sense that people in the villages need gas. People also need electricity. Therefore, this one can help us to produce gas in the community whereby people can use this for their cooking and also to produce electricity, like generators running and then boilers also running, especially for farmers. They can also buy to this idea in order to get electricity running daily and not to rely on only ESCOM. Looking at the resource waste, fossil fuel is a challenge, but here, this time around, biogas is a clean gas when you burn it. It's a natural gas. It doesn't affect the environment. It doesn't affect anyone. And the water crisis also that this plant is taking from the soil is going to reduce, whereby other species are going to grow up, and then grazing animals can also feed on. Looking at the significance of the design, it's less to maintain. It doesn't need big equipment to manufacture. It doesn't need more maintenances, and it's more durable in terms of producing gas. Job creation, I think it will help the younger ones in the village to get something to do in the village and also learn new skills about this biogas production in order to improve their economic skills. Thank you. That is my contact. Thanks very much.
Thank you. Thank you very much, Boniface, for this very interesting presentation on alternatives that we're looking for our carbon footprint. And this, I think, it's one of those projects that actually answer to the issues of also rural employment and so on. We have been informed that I think because of the delays in the afternoon, we need to wrap up our session at 4:30, so that this is going to be used as a plenary session for the next session that is coming. So for my presenters, please stick to your time. I'm giving you 10 minutes to do your presentation. Please don't deal mostly on your introduction, deal also on your results and your recommendation that you are going to give on. So our next presenter is Mulife. He's going to talk on the hydrogen storage. This is also part of the new renewables that we are looking for, hydrogen energy, and he's going to tell us what they've been doing in their research. Say.
Good afternoon, everyone. I hope I'm audible enough. Okay. My name is Molefenzwana, and I'm a master's candidate from TUT, supervised by Dr. M.L. Mahungo. So my title for my project is Numerical Investigation of AB2 Metal Hydride System for Hydrogen Storage. My presentation outline will start with the introduction, background, through to the references. Okay. So metal hydride has provided an alternative storage for hydrogen. The process is a heat-driven compression with no moving parts, less maintenance, and good operational conditions, rather than old method where they used to compress with mechanical components. Figure 2 is a schematic diagram of depicting the mechanism of how hydrogen material are formed. Hydrogen material are formed from two elements, A and B elements, which are depicted by figure 3. So we ask ourselves, why metal hydrides? Okay, metal hydrides are formed by reacting hydrogen with metal alloy. By reacting both of them, the outcome you can find metal hydride and waste energy. The waste energy can be recovered back to release hydrogen by breaking the metal hydride into metal alloy and hydrogen to provide hydrogen to the fuel cell and produce energy for cars and other onboard devices. And again, compared to their closest competitor, metal hydride comes at the top, and their closest competitor are MOFs, metal organic framework. Okay, the problem associated with metal hydride is that they come in a powder form. As they come in a powder form, they have low effective thermal conductivity, and again, and the other problem again is that the hydrating process occurs simultaneously with heat and mass, which causes the scaling of the metal alloy to be hindered. Okay, in the study, titanium, zirconium, vanadium, iron, zirconium, and manganese AB material was used to improve the hydrating time, capacity, operation, design, and design. The material was chosen due to the fact that it has the ability to absorb hydrogen at low temperature, and the process is more rapid than in other materials. Thus, in this study, a graphical approach was used to model the PCT, which is pressure concentration isotherm, instead of using a numerical method. The aim and objective of this project was to design a 2D asymmetrical hydrogen absorption or desorption process. Was modeled using kinetic, transportational equations, and heat and mass. The mathematical algorithm was solved using the aid of COMSOL to profile the temperature, pressure, and velocity distribution inside the metal hydride. Okay, to achieve the aim and objective, a 2D asymmetrical geometry was designed as seen on the geometry figure 7, metal hydride geometry here, with the dimensions in table 3. The material of the reactor was chosen, and the metal hydride domain and hydrogen domain were assigned to the reactor. The model was also integrated into the COMSOL. Therefore, after then, the model was meshed and the simulation was ran. Okay. If then the result did not converge, the similar process was was repeated up until the result converges. After the result converges, the results were taken and analyzed and validated. The mathematical model comprised of mass balance for both gas and solid, energy balance, reaction kinetics, and PC isotherms. Okay. The model was approached by using the assumptions below. The gas phase is ideal from a thermodynamical point of view. The medium is at local thermal equilibrium between gas and solid through to the model having no stresses. The PCT model was modeled from the experimental data to assume the ideal and optimum PCT. To assume the ideal PCT, the PCT to assume this ideal and optimum PCT was because of the researchers such as Maserias and other scientists found out that the plateau of the PCT is flat for AB2 material, metal hydrides. So the model was subjected to various temperature and pressure. So under temperature, it was found that as temperature increases, the concentration inside the metal hydride, the concentration, pressure, and velocity inside the metal hydride also increases. The effect of pressure, we found out that pressure has the same effect on the same effect as temperature on the concentration only, and inversely to the velocity. And again, it has only a slight impact on the increase in temperature. In conclusion, it can be said that the metal hydride PCT model depended on temperature, and again, temperature and pressure improving the hydriding process. Thank you.
Thank you. Let's give him another round of applause. He kept to his time. It's quite an interesting topic. I think there's going to see a little bit of some questions there that will come from the people, especially thermodynamics that I saw in your presentation. So let's get our hands for the last speaker, so that we can then round up and see what questions we're going to give to our panel. Do we have, or is this the last speaker? I think so. So it looks like the other speaker is not here, so we have enough time. We're supposed to have implementation of decentralized PID controller for flotation. I think that this paper did not come in. So let me just summarize what we just said now, so that we can have some questions. We've got enough time to have questions and some discussions before we get to the next session. So we saw the first paper discussing on the issues of cable fault detection in real life in industry. We've got quite a number of different types of insulation and sheathing of the cable. So we're not much really interested in the insulation, because the insulation is covered by armoring wire, as you saw from his paper there. But we're actually really interested in the sheath. The sheath is the cover that covers the outer cable. If you have seen those the guys from municipality installing a stolen cable or a broken cable. So that's the one that is talking about the detection of how moisture and other environmental issues affect on the cable when it's buried underground. We also do not just go and bury the cables underground, but we also prepare the environment. The soil that goes there, we have to prepare sand, some stones, and so on, so that we control the pH of the cables that gets buried there. So his research was to try and see how we can detect early detection of these faults, if it is water ingestion into the cable, if it is just some faults that were created during installation, and then we have some ingestion. So he's got quite a number of suggestions that he is doing. I hope you can get some questions. So this will then allow the municipality to predict where to go and fix the cable before it fails, so that it doesn't cause, so you can have preventative maintenance on your underground cables. And then we had the second one, which spoke about the production of biogas in the rural areas where we were trying to mitigate the issue of these invasive trees that come, and they are so problematic in terms of the issue of climate change, because they absorb quite a lot of water. So they came up with a method of cutting the leaves of this tree, mixing up with cow dung or animal dung, and coming up and producing this biogas. So there's quite a number, some strains that they've done there in terms of the research on what they've come, and I think you've seen some of the results. And the last one was the production of hydrogen through trapping your hydrogen into metal hydrides for your as input to your fuel cells. So you trap your hydrogen into these metals that are hydrogen acceptant, and then you can then release it later when you want to use it in your cells. I don't know, and then so these are the three presentations that we want. I know you've put up some questions, but I would just want to my first question to the first presenter on the cable faults. I just wanted to know, it's not a technical question, but it's sort of a engineering interaction question. Have you worked with the cable manufacturing companies that actually do? Because I know some of them have got quite a number of these techniques that they also give to the municipality for detection and so on. And then the second one was, does your detection also just only apply on PVC and XLPE? Do you also do detection on other insulations such as paper insulated cables and lead insulated cables? That's my question to you. And to the second presenter, my question is really on, if you can maybe just elaborate just a little in summary, how you think your project is going to impact on the issues of renewable and just transition that we are discussing here as part of the topic. Is what do you think is going to be your impact of your production of this methane and so on, and how does it compare with other polluting gases that we produce in industry? And last one is on the metal hydride. I just wanted to check to you, don't you think there's a little bit of some contradiction? I don't know if you can just check. I saw your first reaction is an exothermic reaction. So you produce heat in the process of producing that hydride. I saw you've got metal hydride plus Q in one of your equations there. So when you increase the temperature, I saw you said the increase in the effect of temperature increase in your production showed some increase in terms of concentration of your gases that are produced. How do you explain that in terms of thermodynamics? Because we know when a process is producing heat, by putting more heat onto it, it will reverse your reactions to the reactants. If you can put that in mind. Do we have any other questions from the floor for our panel? If I can pick up some hands.
1 year. Any more hands? Okay, while you are thinking, please say.
Okay, good afternoon. My name is Katleo, and I'm from the National Ports Authority. My question is directed to Gideon. I just wanted to find out in terms of the measurement of partial discharge on low voltage cables. I know it's quite popular with high voltage cables because of the price that's associated with those type of cables, and because there's a lot of sheath voltage build up or on the higher voltage cables. But in terms of low voltage cables, they don't tend to have those type of problems. Most of the problems are around how the installation is done, and that's how mostly the insulation gets damaged, or if there's faults. So there's already systems that exist, like the online monitoring of partial discharge on high voltage cables. My question would be then to say that, knowing that low voltage cables, that network would be very vast. So the number of cables that you would have on a low voltage network would be far more than what you would have on a high voltage or a medium voltage network. So my question is, how will you then discriminate where you do your measurements? Because I know this test equipment is quite expensive.
Can we give them the time to respond? We will start with the last question, which is presented the first presentation, and you can answer the other questions that have been asked as well. Yeah, you can press the green button there.
Yeah, no, thanks very much for your question. As I recall, you said, what is the impact that is going to give to South Africa? This feedstock and the cow manure production of methane that we're doing, most engineering companies, most dairy companies, especially with the farmers, they use a lot of electricity when it comes to their dairy machines that the cows goes on. They take a lot of electricity. So having this idea, we can be pushing feedstock and then getting gas, and then the gas that we're gonna get, we use it to run generators, and then the generators produce electricity to the farm. So the farm wouldn't be depending on ESCOM for electricity, but depending on its own recycling of the cow manure to gas in a closed system, like continuous system. Also, when we look at the people that are in the village that are struggling, especially with this load shedding, they need to have water, hot water to bath, especially in cold seasons. If we can also buy by this idea, I'm sure we can build a plant that we can use this gas to boil water. So it's going to be like a hot water boiler, that the gas is going to feed to that hot water boiler, and then we can be supplying the community in the village. So it's one of the things. And it's not only the black wattle alone, but any other feedstocks that is an organic material, we can use it in a batch process, because the continuous process is also very expensive. It's very, very expensive in a way that it involves a lot of work, blockages, pipe blockages, and a whole lot of stuff. But then with the batch, we just get the organic material, push it into the reactors, close it, and then tap the gas, and then that is it. So thank you.
No, thank you very much. You can switch off your mic. Thank you very much. I think I've seen some of this application actually it is a small batch, but they are not using other. The feedstock was just only the cow dung. They were using cow dung and maybe domestic waste that they put in a small little tank, and they produce. So they did a small little, it's in Limpopo. They did a small little pilot plant where they're feeding one house, and this woman is actually cooking. Everything is done from this biogas. So they go in the morning, they collect, they put the cow dung in the digester,
and then it feeds, the gas feeds into the stove. They built such a small little portable stove that is for that, but it's still a pilot plant. They're thinking of expanding that thing. So I think maybe some of your things that we would do is also to look at the value chain of all those other things that would come with that in putting this material into use. Let's get the second question.
The second question about the temperature. We all know that there are 3 temperatures involved when you're dealing with this particular project, or when you're dealing with biogas production. We have the psychophilic, the mesophilic, and the thermophilic. The psychophilic is when the temperature ranges between 0 to 20. It's like your normal fridge. Therefore, bacteria are not all that active at that stage. But then with mesophilic, it starts from 20 to 45. And this temperature is always the best for biogas production in terms of 35 days retention time. But when you take it to thermophilic, you increase the temperature. You can get gas the first day, but the rest of the days, it becomes a challenge for the bacteria because you're forcing the bacteria to do things that it cannot do. So that is why we stick to the mesophilic.
Okay, thank you very much.
Thank you.
Yes, it's up to you. Yes.
Okay, thank you, Chairperson. Maybe the first questions that you had, whether or not I was working with cable manufacturer, I will take that question as my homework. In terms of, we do have a couple of manufacturers that do deliver cables to us, and they do produce the quality certificates. But the tests that they are currently doing, they are almost like your normal tests that won't be able to detect if the insulation has been damaged. But I suspect there may be other tests that they are doing that they are not telling me. So I'll take that as my homework. I'll go and find out, Chairperson. In terms of whether or not I've considered other cable insulation material, it is a very tricky topic, Chairperson, in the sense that most of these detection techniques cannot be universally applied to all the cable insulations. For example, if you have your partial discharge, what you're doing basically, you are basically feeding a very high voltage onto the cable insulation. So if you have like a paper insulation or any material that was not really designed to handle those high voltage insulation, it's just going to damage it and you're not going to get the results. So you have to be very deliberate about which installation you're going to study. And I decided to choose the popular one, which is renowned industry-wide, the XLP insulation or the PVC. The literature has shown that it is renowned for withstanding high voltages, and this is what we are also using at Transnet. So again, so that my employer can rest with ease, knowing that my studies would ultimately benefit them, and they will also allow me time to study. You have to study on something that will benefit them as well. Yeah, but the techniques are very specific to the kind of insulation that you're going to use. Coming back to the partial discharge application on low voltage, also it is a very difficult issue because not many studies have been done on low voltages, but also what I have found is that low voltage cables, the reason why I'm even considering using the partial discharge method is that they have been overly designed, especially the PVC and the XLPE insulation material. They have been overly designed in terms of the voltage that can be used. Therefore, you can, in principle, apply a partial discharge. Now, in terms of where do you discriminate or how do you discriminate which parts you're going to do? So if I just come back to my employer, we have what we call annual shutdowns. Basically, this is where we do major maintenance that we wouldn't otherwise do under normal circumstances. So that is where we're going to apply specifically on a specific section, test those cables using either partial discharge or broadband impedance spectroscopy when the line has been shut down for maintenance, because we will be able to detect that the cable is on its way to failing. You know, instead of just doing those major, because these cables are buried underground, we can't be able to see what is happening. But if you are able to test it and you can see that it's on its way to failing, and we can tell that by studying the integrity of the insulation, then we can plan the maintenance accordingly. Thank you, Chairperson.
Okay, thanks. Our last speaker.
Okay, Chair, then I heard you properly you spoke about if the thermodynamical property of the metal hydride, if then it will not decompose, right? So the material that we choose, it can withstand a lot of high temperature from 0 to 150 degrees Celsius. And again, to counter the heat release, we also trying to recover the energy so that we could use it back to decompose it when we need the hydrogen. So that's how we work around the metal hydride reactors.
Thank you. Thank you so much. Do we have any other questions before we round up? Because our time is also up here. If I can get any question from our just maybe last two very summarized questions. I'll take you first and then the gentleman in front here second. Thank you.
Afternoon, colleagues. Question is directed to the first speaker. I think in as much as the focus area on the topic was about the early detection of the fault. And one of the cable faults that was highlighted in your presentation deals with theft and vandalism. And we know that in South Africa, especially with the municipality, TFR specifically, is one of the areas that actually affect the operations, which in turn affect the service delivery. I'm not sure whether, as part of your research, I just want to know if your research did look into preventative measures to cable theft and vandalism, as well as any other alternative in terms of the type of conductors, of the lowest in terms of cost as compared to the cost of copper cables. Thanks.
Okay, thank you. Let's get the last question.
Hi, my question was regarding the methane gas. So you've termed it as a solution for, say, rural areas, areas where you have no access to power. Have you looked at the cost of the technology in terms of accessibility for people in the rural areas to be able to utilize this technology? Because if they have to, okay, the product, cow manure or whatever it is, will be cheap and available. But the actual equipment, if it's too expensive, then the market break-in is too high. That's the one part of it, and also the safety aspect with regards to producing a gas which is a flammable hazard, in terms of the safety aspects of how you would educate people or how you would, store that gas so that you don't end up with more hazards or more safety concerns than the benefit that you're creating.
Thank you, gentlemen. Can you please summarize those questions in less than 30 seconds? Because
Thank you very much for your question. I'm looking at the safety that you talked about. When such a plant is built for the community, there's going to be a fire arrestor. So it's a pipeline whereby you connect the fire arrestor to the pipeline, then it connects to wherever that they want to tap or wherever that they want to fill their methane gas. Then, whenever there is an issue, it doesn't cause a problem. So you safeguard where you are putting this plant in order that they wouldn't get access to it directly. But then it's going to be monitored by professionals who will always be looking at the temperature and the pH and everything of the plant. Yeah, thank you. And when you talk of the solution, that we can use is not only specifically for rural areas. It could also be done in developed areas, but the problem is that with developed areas, I think we are getting enough electricity as compared to those in the rural areas. That is why my focus was there. But then if in a developed area also having electricity crisis is a simple thing that they can buy too, and it's going to help them. Yeah.
Thank you.
Thank you.
Let's get the...
Okay, thank you, Chairperson. The first question regarding cable theft, I completely agree with you. But my view, and I have a very strong view on this is a socio-economic issue, the issue of cable theft. So it is a man-made problem. That is why I decided to exclude it from my study. I know it exists, but it is not an engineering problem. If you were to solve the socio-economic issues, then you have also automatically solved the cable theft issue, in my opinion. That is why I'm not even going to study it, because I'll just be wasting, I will not be dealing with the core issue or the root cause. Okay. I hope I've answered that. Second question, we have tried to implement other cable conductors which has a mixture of elements in it that really makes it very difficult, or it disintegrates whenever you try to melt it for other purposes. We are busy piloting that project. So far, it has shown a little bit of problems on where we have implemented it, but we are looking into that direction. Thank you so much, Chairperson.
Thank you so much. Thank you so much for the response from our presenters. I can also just add on that. Your name, say?
Thokozani Mhlongo from Transnet National Ports Authority.
Shongwan.
Thokozani Mhlongo.
Thokozani. Thokozani, yes. I also want to agree with him. Some of them, they are socio-economic, but what we had done also because most of the solutions would definitely come from the cable manufacturing companies, not from the end user. So we've got some materials that are being used now for cable theft purposes. I think we have also seen, as a response, the removal of copper on your distribution lines, putting ABC, which is area bundle conductor, which is of aluminium, because of its lower value. But I would think with time, all of them, the value of aluminium will also go up. So you go back again to the socio-economic conditions, but also got new materials like copper-clad aluminium, which is we put aluminium inside and then we coat it at the back, at the end, with a skin of copper for conductivity, to increase conductivity. It reduces the value of the cable, but then you have to design a much bigger cable than what we have with copper because of the conductivity of aluminium being lower. Those are some of the response. Then you've got copper-clad steel, which we use for your earth wiring. Instead of using a copper straight wire, which is outside, we just use a copper-clad steel. It's also a skin of copper outside and then steel inside. If the guy is cut, it's very difficult to cut, and also you can't sell that product because no one can buy such a material. So there are some of the responses that are being done through engineering to respond to this. But I think what he's saying is, let's solve as engineers the issues of unemployment and create more jobs, create industries in Africa, try to beneficiate our materials here so that we can create more value jobs in Africa than sending materials outside the continent for that, and therefore creating jobs for Europe and other countries, and so on and so on. But as your chair, I want to thank you all for attending this session, and also for your patience with our presenters for the 3 papers that we have presented here, which are quite very much good research that is being done. Can we please give them a final round of applause as they go out on the... And to you, our audience, I say thank you very much. Our session ends here. Well, I think we're going to the last session for this. It's going to be in this this session. For those who want to go out and refresh and then come back for the last session, I say thank you. This session is closed.